Hey, good afternoon. 25th of March here. This is a quick introduction about the DIY lava lamp presentation that we've prepared for week 2 for our interactive advanced concept presentation for Chem 125. And in starting to look through what I needed, I prepared all of my tools and my ingredients, but I was really curious about the chemical reaction. So if you just Google molecular formula of Alka-Seltzer, you actually get the empirical formula. This was from the PubChem source on the NIH website. It didn't necessarily tell me much about the chemical reaction until I dig a little deeper. And here's what we find out. Alka-Seltzer is actually a dry tablet, and it has dry components of sodium bicarbonate and citric acid compressed into the tablet. And when dissolved in water, we see that a byproduct of sodium citrate is produced as a product. And then we also see carbon dioxide and molecules of water produced. Carbon dioxide is the star of this show. And without further ado, here is my recording. Oh. All right, Saturday afternoon in my kitchen. We're going to do a DIY lava lamp. And per some instructions online, we know that for this experiment, we need a container, and I have measured this container with water. This container holds 4 cups of water. So I poured that out and then remeasured 1 cup of water. That fills this plastic container with about a quarter of the way. We have 1 cup of water. And then the other parts of this demonstration are 2 cups of oil. Are going to fill my container to about 2/3, and then we're going to add some food coloring and let that settle, and then the final step will be an Alka-Seltzer tablet, and then we'll watch the magic happen. Okay, so first things first, we're gonna pour the oil in, and pretty basic concept here. We all know that oil and water are not soluble, and this is due to a density difference. They don't mix, and right now, since I have just combined them, they will separate if they are left to stand, which we want. So I'm gonna set this down, let it settle, and talk about the rest of the density situation. So water is more dense than oil, which is why we see the water settle to the bottom. The oil settles on top. Because of the nature of different molecules, solubility in one or the other or both is not a plug and play. The food coloring I'm using today, I believe, will not be soluble in water. We will see here in just a moment as soon as it settles. I'm going to add 8 to 10 drops of food coloring. I have green here. And what I'm hoping for is that it will be more dense than the oil, similar to the water, and that we'll see the drops drop down to the lower layer and dissolve at that point in the water, giving me a colored water with more of the yellow oil layered on top. Okay, I think we're getting close. I'm gonna add my drops. I don't have a dropper, so I'm just gonna go real slow. And yes, I have nitrile gloves because St. Patrick's Day has passed. And I no longer need green hands. I don't think that's enough food coloring. This is an old bottle. I'm just gonna give her the old extra. Okay, well, we did see successfully, I'm going to hold this up closer, all of that food coloring dropped to the very bottom. A few particles still remain. They have adhered to the upper level of the glass or plastic container. That should not impact our experiment. We are going to follow this green water now as I add my Alka-Seltzer tablets. And I'm going to go for 2 because I want to see a good reaction. Before I add these, get them ready, and get my vessel into good view of the camera.
Okay, I'll jump to the next recording. Just one correction. I misspoke when I had said I was hoping to drop the food coloring into the mixture, and I didn't want it to be soluble in oil. I wanted it to be soluble in water and insoluble in the oil. So, okay, here's the goods.
Okay. Shifted the perspective just a little bit, moved the camera so that you can actually see the reaction, and in go the tabs. A few extra pieces. I'm going to agitate a little bit to make sure the food coloring is dispersed. And there you have it. A DIY lava lamp, green food coloring with 1 cup of water, 2 cups of olive oil, and probably more green food coloring than I needed, but hey, the green bubbles look pretty cool. I know. Enjoy.
All right.
Okay.
I was able to hold the
Homemade lava lamp. Pretty neat.
We have some sunshine here in Anchorage right now, so got some better backlighting on the vessel. So real quick, just to revisit the whole experiment, we had water layered under oil with some green food coloring added to the water, and then an Alka-Seltzer tab dropped in. And based on the formula, the equation that we expected to happen, we knew CO2 was going to be a byproduct of the Alka-Seltzer tablet as the sodium bicarbonate and the citric acid reacted in water to generate sodium citrate, carbon dioxide, and water. So as the CO2 is produced, the gas, which is a light density, rises up through both layers, the water and the oil, taking with it particles of the food coloring and the now dyed green byproduct of water. As the bubbles hit the surface of the container of the liquid interfacing with the outside air, the CO2 dissipates, and that concentration of water, now dyed green, which is more dense than oil, falls back down. That is the process of the rising bubbles and the way they fall back down. All right. This has been a fun afternoon. Thank you so much.